Coming to the next part, that is metabolism of catecholamines. Many amines including catecholamines are the substrates for monoamine oxidase, an enzyme which converts them to the corresponding aldehydes, and this aldehydic intermediate is rapidly metabolized, usually by oxidation or reduction in phase 1 reaction. By oxidation, it is converted to acid by the enzyme aldehyde dehydrogenase, but in some cases by reduction to the alcohol by the enzyme aldehyde reductase. The acid or the alcohol formed may undergo phase 2 reaction like glucuronidation reaction to get excreted in the urine. MAO, that is monoamine oxidase, converts catecholamines to the corresponding aldehydes by oxidative deamination. Oxidative deamination means conversion of this CH2 group to aldehyde group, that is the CHO group, along with deamination, that is removal of this amino group. Similarly, here in the norepinephrine also, oxidative deamination means conversion of this CH2 group to the aldehyde group along with deamination, that is removal of this amino group. The next enzyme involved is COMT, that is Catechol O-methyl transferase, which was found to transfer the methyl group of S-adenosyl methionine to the catechol ring of catecholamines. That is, it transfers a CH3 group from S-adenosyl methionine to OH group. So, this is the catechol ring which contain OH group, and OH group of this catechol ring is converted to OCH3 group, that is the methoxy group, by transfer of a methyl group from S-adenosyl methionine. Thus, here point to be noted is that catecholamines are subject to metabolic inactivation by oxidative deamination when catalyzed by MAO or O-methylation when catalyzed by COMT. MAO is a mitochondrial enzyme present in the nerve ending, while COMT appears to be largely extraneuronal. The levels are highest in the liver and the kidney. Let's take example of dopamine. Here in the structure 1, if both R1 and R2 are hydrogen, then this is the structure of dopamine. Dopamine or any other catecholamine is either catalyzed by MAO or COMT. Let us first see if it is first catalyzed by MAO. Dopamine, when catalyzed by MAO, is converted into 3,4-dihydroxyphenyl acetaldehyde. Here, this CH2NH2 group of dopamine is converted into CHO group by MAO enzyme by the process of oxidative deamination, as we have discussed. Now, in the next step, in the presence of aldehyde dehydrogenase, this CHO is oxidized to form the acidic group, the COH group, to form 3,4-dihydroxyphenyl acetic acid. Then in the next step, this 3,4-dihydroxyphenyl acetic acid is catalyzed by COMT to form homovanillic acid. In this reaction, this OH group is converted to OCH3 group by O-methylation process. But if 3,4-dihydroxyphenyl acetaldehyde is catalyzed by aldehyde reductase, then this CHO group is converted to alcoholic group to form dihydroxyphenyl ethanol, which in the presence of COMT will form 3-methoxy-4-hydroxyphenyl ethanol, which further undergo phase 2 reaction. This is the process undergoes when the dopamine is catalyzed by MAO. But if it is catalyzed first by COMT, then it forms 3-O-methyl dopamine by converting this OH group to the OCH3 group. Then in the next step, it is catalyzed by MAO to form 3-methoxy-4-hydroxyphenyl acetaldehyde by converting this CH2NH2 group to the CHO group. Then in the presence of aldehyde dehydrogenase, this 3-methoxy-4-hydroxyphenyl acetaldehyde is converted to homovanillic acid, or in the presence of aldehyde reductase, it forms 3-methoxy-4-hydroxyphenyl ethanol. Both of these products, that is product 5 and product 6, undergo phase 2 reaction to get excreted in the urine, like glucuronidation reaction. Now let's take another example of norepinephrine. In this structure, if R1 is OH and R2 is H, then this structure is of norepinephrine. Norepinephrine, when catalyzed by MAO, is converted into a glycol aldehyde, that is 3,4-dihydroxyphenyl glycol aldehyde, in which this CH2NH2 group is converted to CHO group. Then in the presence of aldehyde dehydrogenase, there is the formation of 3,4-dihydroxymendelic acid by converting this CHO group to the acetic group, that is COH group. And then in the presence of COMT, there is the formation of 3-methoxy-4-hydroxymendelic acid or vinyl mandelic acid. But if 3,4-dihydroxyphenyl glycol aldehyde is catalyzed by aldehydic reductase, then it will form dihydroxyphenyl ethyl glycol by converting this CHO group to the alcoholic group. And then in the presence of COMT, it forms 3-methoxy-4-hydroxyphenyl ethyl glycol, which undergo phase 2 reaction. So both of these final product, that is product number 5 and 6, also in the case of norepinephrine, undergo phase 2 reaction. But if it is catalyzed by COMT, that is, if the norepinephrine is catalyzed by COMT, then it form normetanephrine by O-methylation of the OH group. Then normetanephrine in the presence of MAO forms 3-methoxy-4-hydroxyphenyl glycol aldehyde, which in the presence of aldehyde dehydrogenase is converted to the final metabolite, that is vanillyl mandelic acid, which undergo phase 2 reaction, or in the presence of aldehyde reductase will form 3-methoxy-4-hydroxyphenyl ethyl glycol, which undergo phase 2 reaction. If we talk about epinephrine, then all the reactions undergo are similar to the norepinephrine, and the final product or the final metabolite is vanillyl mandelic acid in the presence of aldehyde dehydrogenase, but the final metabolite is 3-methoxy-4-hydroxyphenyl ethyl glycol in the presence of aldehyde reductase. But if it is first catalyzed by COMT, that is, if epinephrine is first catalyzed by COMT, then it forms metanephrine. It forms metanephrine in the place of normetanephrine, and this is the only difference between the metabolism of norepinephrine and the epinephrine. But the final product are same, that is vanillyl mandelic acid or the 3-methoxy-4-hydroxyphenyl ethyl glycol in both the cases of norepinephrine and epinephrine, which then undergo phase 2 reaction.